Good evening, all. Good evening, dear participants. Am I audible? Can you see my screen? Good evening, all. So welcome to this free webinar on machine learning algorithms. Good evening, all. So before starting about the machine learning algorithms or the math behind it, talking about that, can you guys post about what are the types of machine learning? So you should have some previous prior knowledge about what is machine learning and things around it, so that we can discuss elaborately in this 1 hour about a lot of algorithms, how it works, etc. in this session. Yes, so talking about machine learning algorithms, so if you want to choose a machine learning algorithm for your machine learning project or the purpose, so if you ask me about how to choose the right machine learning algorithm, then I'll suggest you 3 steps. So first one is the nature of the problem you are going to solve. The next one is the nature of the algorithm. So once you know it, then only you can utilize it. And then finally, performance comparison. Talking about the nature of problem, so machine learning, talking about the nature of problem, you can categorize machine learning into 3 types. First one is supervised learning, next unsupervised learning, and then reinforcement learning. And talking about reinforcement learning, it's a game based, like every time it runs, so it's trying to improve on its own. So it's a high end. So coming into the basics, once you are thorough with your supervised learning and unsupervised learning and deep learning, then only you can utilize your skills or improve it in reinforcement learning. Talking about the base of machine learning, you should have prior understanding of supervised learning and unsupervised learning. So in supervised learning, we will be having a labeled data. So we will be having an output column or a target column which we just want to map with the features you are having in your data set. And talking about supervised learning, based on the target or the label you are having, it can be classified into classification problem and regression problem. And talking about unsupervised learning, we have clustering types, because in unsupervised learning, we don't have labeled data, so there won't be any labels for you to map. And there we will be clustering the data to find togetherness there. So we will be separating our data into parts, and the important groups will be identified. So that will become under clustering. So talking about clustering, we have k-means clustering algorithm, which is an important one, mean shifting clustering, DB scan algorithm. So these are some of the clustering algorithms. So if you want, or if your data is unlabeled one, then you can use these algorithms. Talking about supervised learning, so if your target is classification or it's a labeled data which has 2 or multiple classes, then it will be classification problem. And talking about regression, when you have or your target is a continuous one, that will comes under regression problem, right? So talking about that, a simple example in supervised learning, we have labeled data, and so this is what a comparison of what is called as regression and what is classification. So if you are going to predict based on the data in machine learning, if you are going to predict the target as either hot or cold, then it comes under classification problem. And if you are going to predict a continuous value which is not belonging to any of these classes, it's a continuous value, then it will be a regression problem, like what's the temperature going to be tomorrow, what's the price prediction, or you can also sell salary prediction. So those will come under regression problem. So for classification problem, we have a set of classification algorithms like naive Bayes classifier, decision tree classifier, random forest classifier, XGBoost, and all is available. Talking about regression, some algorithms play dual role. They have both for classification as well as regression. Talking about regression, we have some regression algorithms. So for example, decision tree has decision tree regressor. We have support vector regressor here. So like that we have the regressor algorithm. So I hope the first point is clear. Are you guys clear with what is the nature of the problem? With that you can sort down what all the algorithms you have now. In that, if you want to decide or if you are going to use that, you need to understand the nature of the algorithm, which we are going to see next. Can we continue with the next one? Can I get some response in the chat box? Dear participants, why it is so silent? Please be interactive. If you have any doubts, you can post it in the chat box. I'll be replying to it. And in between, I'll try to ask few questions. So if you know the answer, whether it's correct or not, please post it down in the chat box. Clear? So talking about the nature of algorithms. So yeah, we have a set of algorithms, right? So we'll see some of the important algorithms and the math behind it. Starting with linear regression. So what is linear regression and logistic regression? We can have multiple algorithms which comes under linear models. Yes, good evening. Linear models. So if you, which library we'll be using for machine learning? I hope you have the idea about it, which is scikit-learn, right? From sklearn, we will be utilizing lot of machine learning tools and algorithms also. And if you go into the package inside of your linear model in sklearn, you will be finding linear regression, logistic regression, then polynomial regression, lasso, ridge, etc. Those comes under linear models. So first we'll cover what is happening behind a linear regression. As the name itself suggesting, it is an algorithm which can be used for regression problems. So what is a regression problem? The output is a continuous one. So it is a statistical method which assumes a linear relationship between the variables, meaning the relationship can be represented by a straight line on a scatter plot. Do you guys know what is a scatter plot? You will be plotting the points like this and you can draw a straight line. And you will be having a x-axis and y-axis, right? So this is what a linear regression is. If you go with x-axis is going to be your features or your columns you are having in your data set, and y is the target or the variable which you are going to predict. So that's why these are independent variables and these are dependent on this independent variable. So that or independent variable. So in y-axis it's the target and in x-axis it's the features. And if you plot it, okay, in like a scatter plot and draw a straight line, that will give you a linear regression. So what is that? We'll understand furthermore. So I'll go with a simple example. See here, understand this. We are going to make a machine learning problem. So where we are going to predict the umbrellas sold based on the rainfall in millimeter. Okay. So you can see. So I'm just plotting. For example, I'm having a data set which is having, like for example, at the value of 85. Okay, when the rainfall is 85 millimeter, the umbrella sold is 15. Okay, then at 86 the umbrella sold is 16. Like that, I am plotting all my values from my data set. So this is a single feature, only rainfall and target is umbrella sold. And once you plot it, what I am trying to do is I am drawing a straight line which can cover most of the points inside of it. Fine, so I have drawn a straight line. So what you can see from this? Can you see a trend which is happening here? Whenever the rainfall in millimeter increases, what we can see here is the umbrella sold is also increased. Am I correct? Can you see the trend, dear participants? When the rainfall value increases in X, we can see the value of Y also increases. So we don't have any point which is having, when the rainfall is high, the umbrella sold is also high. So if I have a new value, for example, if I want to make prediction using linear regression, what it will do is, if I want to predict what will be the umbrella sold if my rainfall value is 150, so it can take this straight line and from that it can find the coordinate of y, that will be a value, right? So it can give you the answers. Am I correct? It can be done, right? Understood? For example, if I want to predict here, so the value of x, so it can give the respective value of y by getting it from there, right? So it can draw a straight line, just ignore the straight line. See here, so at this point, what is the value? So that will be your output, that can be given by your algorithm. So that's what happening behind a linear regression. So once we go deep further, I'll explain about the components of it. Are we clear with linear regression, how it works? And this is a single column, okay, univariate. Talking about the straight line, usually you would have learned about this formula, which is going to be y equal to mx plus c. Am I correct? It's a formula of a straight line, where what is y value? Y value is you are going to predict the y value, which is your umbrella sold, for example. And what is x value? X value will be the input you will be giving. If my rainfall value is this value, what is the value of y? That can be found using this formula. You need to have a value for your c and m. So what is c? What is m? M is the gradient, okay, which is going to be the difference in y divided by difference in x. So if you draw a slope, you can get the values of m. Based on the line, how oriented it is, the value will be obtained from the slope. And what is the value of c? C is the point where your straight line passes your y-axis. See here, if I talk about here we do. If I want to find the value of y, what I can do is, so this straight line will be passing here, right? So it will be passing. So if you extend the straight line, this y value will be passing, right? So this is the value of your c, where it is passing your y-axis. That will be the value of c. So with this line, by substituting the value of m and c from your straight line with the value of x, you can obtain the value of y that is happening in your linear regression. So this is a used car data set. Actually, if you have worked on machine learning project, you would understand this data set. So we are having a lot of features, including the car name, the year, present price, fuel type, etc. So here what we will be predicting is the present price. Sorry, it's the selling price, this last column. So this is going to be your target. Okay, so what will happen is you will be plotting all these features. Here we used only one feature, which is the rainfall. Okay, so instead we are going to use multiple features to predict the selling price now, or we can go with another one. So first, instead of going with all these features, I'll go with age. Okay, consider age in x-axis and the selling price in y-axis. What is age is how many years for that car, how many years it has been used. So here you can tell the trend, which is going to be like this. Am I correct? Because when the car is new or when the age is very less, so if you are having a 1 year old car, okay, one guy is used to that car for 1 year or less than 1 year and he is going to sell it, so the price will be little bit high. And imagine same case for a car with which has been used for 10 years. When the age increases, the used car price will decreasing. Am I correct? The trend of it. So here we are plotting it and drawing a straight line. This is simple linear regression because we are using only one feature, which is going to be that age. What if you use others also, like year, what's the fuel type, what's the seller type, etc. When you plot other features also, so that will comes under multiple linear regression. Okay, so that's what the difference between simple and multiple linear regression. And talking about best fitting line, so see here guys, here I have drawn a straight line, this blue color, which is almost passing through the center of every point, right? So here see this red color line, that can also pass through every point. So how will you find the difference, which is the best fitting line? How will you get the best fitting line? So that is actually done by the algorithm. So I'll tell you how it is doing. So what is the idea behind this? If you also want to draw a line which pass through every point correctly, or you cannot actually draw a straight line which passes through every point, right? So we will be plotting a line. What's the condition here is, the whole idea of linear regression is to find the best fit line which has very low error. Okay, so the error, if you minimize it, that will be a best fitted value, best fitted line. So how will I tell you what is error is? So the line of best fit is determined by minimizing the difference between the actual value and the predicted value. Okay, talking about that, see here, this is my line and these are my points, and you can see my point is here. This is the original y, okay, sorry, the original value, but in the straight line the value of it is here, right? This is the predicted or the given one. So the difference between your original one and the given one, this is called as the error value. So for this point you will be getting one error, right? For this point you will be getting one error, for here you will be getting one error. Like that, once you calculate, once you sum up all the error, you will be getting a bulk value, right? That value for this line, okay, that is the error value for this particular line. Like that, if you calculate for your blue color line and red color line, we will be getting some numerical value in the output. So that is, I hope you understand. I'll draw and tell you. So what is the difference? So this is the predicted one. For red color it is near, so the error value will be less, but when for blue color it will be this much value, so that will be a numerical value. So like that, for every line which is possible, you can calculate a error value, and that value, how much less it is, will be giving you the best fitted line. So how will I tell that? I'll tell you with this, see here. So like that, we will be calculating the error value, right? So this error value will be available later on, okay? I'll tell you which line has the lowest error, that will be the best fitted line. Am I correct? Imagine a situation in the straight line, all the points are exactly on the straight line. Imagine not this difference, imagine this orange color alone. Every point are exactly now passing through the straight line. Now what will be the error value? Do you understand the situation what I am telling? I am having a straight line and every point are exactly on the straight line, so the error value will be 0, right? Obviously the difference, it will be 0, so totally it will be 0. So the best fitted line is nothing but, if a line passes exactly through all the points, then the error will be 0, okay? But practically in a data set, it is not possible. Every line cannot exactly pass through that, okay? So the line cannot exactly pass through all the points. So how will we select the best value is, we will be comparing the value of each line, and which line has the lowest error, that will be selected. Okay? Are we clear how the best fitted line is? So in this red and blue, which has the lowest error, or you can have multiple lines, whichever has the lowest error, that will be the best fitted line. So if you want to manually do it, you can also. Okay? So that's about our best fitted line, how it is found. I hope you understood that. And talking about the formula, this is nothing but y equal to mx plus c formula. Y, this is x, this is your m, this is your c value, which is represented as beta naught and beta 1, etc. Talking about multiple linear regression, the beta 0 or the c value will be constant, because that is one value will be obtained. For how many feature you are having, that much you will be calculating. Okay, m1 plus m1 x1 plus m2 x2, like that we can have multiple linear regression formula. These are the variables there. The independent variable, which is going to be your columns, like the age of it or the owner type, like that, and the intercept value of your y coefficients and the number of observations. This is a practical formula. And actually, if you ask me what is the method the algorithm uses to achieve this, is it is called as ordinary least square method. So our algorithm uses this. It's actually a mathematical formula. With that, you can get the best fitted value of your beta 0 and beta 1, so that you can draw a straight line. So the algorithm uses this formula. Beta 0 is going to be y bar minus b1 beta 1 into x bar. Here x bar and y bar are nothing but mean values of that particular column, right? And here if I get the beta 1 value, I can find beta 0. So the beta 1 will be summation of x value minus x bar, the mean value of that column, multiplied by y minus y bar divided by summation of x minus x bar, the whole square. With this you can get beta 1 value, and if you substitute it here, you will be getting beta 0 value. With that, you can go and substitute here. That's what the algorithm. Yes, you can ask doubt. And this can also be represented in a matrix format, which if time permits in the end, I'll tell you hands-on how to build a linear regression and model from scratch with this matrix format. So this is the formula if you go with the matrix format. The formula to calculate your beta 0 and beta 1 is x transpose the matrix multiplication with x. You have to take the inverse of it and then matrix multiplication with x transpose and with y. If you apply this formula, you will be getting your beta 0 and beta 1 value, which is going to be your intercept, and your m value, which is going to be the gradient value. With that, you can proceed with building your algorithm on your own too. And this is what the a library, if you want to import it from sklearn.linear model, you can import linear regression. Clear? Actually, we are conducting one machine learning internship which is going on. So if you are interested, you can use the link which is given in the chat box. So I am taking it. It's from 7 to 8 p.m. You can join as an internship user too. Already 18 days has been completed. So if you want a trial, you can watch today in this YouTube channel at 7 to 8 p.m. I will be seeing today calories burnt prediction project, which is a regression project. So moving with the next algorithm, which is going to be logistic regression. So it is under the family of linear model. So this linear model, we can import linear regression. Similarly, you can import logistic regression. Even though the name contains regression, it is actually for classification problem. Okay, it's not a regression algorithm, it's a classification algorithm. And talking about that, logistic regression, how that it has the name regression is, it is much similar to linear regression, but except how they are used. So linear regression is used for solving linear regression is used for solving regression problem, and logistic regression is used for solving classification problems. So here logistic is for classification, and in logistic regression, instead of fitting a regression straight line, we will be fitting an S-shaped logistic function which gives you a maximum of 0 and 1. What is classification? Once again, talking about classification problem, I hope you understand it's the types of machine learning problem. It's a hot or cold or cat or dog, like that, binary, or you can have multi-class also, low, medium, high. So you can have 5 classes, 6 classes and all. I'll tell you how it's done. So here the 0 or 1 or the binary classification can be obtained with logistic regression. So this is the formula, 1 by 1 plus e power minus x. So this is the formula of sigmoid curve. If you apply your values here and plot it, you will be getting a sigmoid curve like this. And based on it, we will be having a threshold value. So if your new point, your new data, if it is above this value, if it's around 0.8 or above 0.5, it will be given as 1, predicted as 1. And if it is below 0.5, then it will be given as 0. So we can have this binary classification. So you can have two types here. One is binomial logistic regression, where 0 or 1, pass or fail, or yes or no, hot or cold, like that, binary classification. Talking about multinomial, it can be 3 or more, cat, dog, sheep, like that predictions. So this is a binary classification and this is a multi-class classification. And exactly how the formula is applied is, see here, this is the formula of a straight line. When you go for logistic regression, this formula, the value of y is applied or substituted here. 1 by 1 plus exponential of the negative value of this particular value. If you plot it, you will be getting a sigmoid curve, and the new point will be predicted using this particular formula. And this is a sample data set, which is a Titanic prediction. Have you guys seen it? These are all the features, and finally the prediction column is survived, whether it is 0 or 1, whether they have survived or not. And this is the formula which has been applied in logistic regression. And talking about binary, you can understand here we are using some threshold value to predict. Okay, fine. But how will I do it if I have multi-class like this? What if I am having 3 or more classes? Will I be having another threshold value here? No. So how it is actually done is, it is done based on a method which is called as one versus rest. Okay, it is called as one versus rest method. See here. So this logistic regression, what it will do is, here, see here, this is your target, which is you have 3 classes, O1, O2 and O3. And first time what it will do is it will set O1 as a single class and combine O2 and O3 together. So it is going to be once again a binary. See here, this one versus these two. And then the next time it is going to consider this guy and combine these two. And then the next time it is going to combine these two and consider him alone. So it is like turn them into binary. Based on it, the output will be like this. It is the one versus all or the one versus rest method. Can you see it? This is considered as a separate class. These two are together. Then these two. Then these two. And with that, you will be getting an output which is like this. Based on the probability. So my output now, if I give a new data, it is giving me an output like this, which is O1 is 0.20, O2 is 0.25 and O3 is 0.55. From this, who is the most probable here? Can you tell it with a numerical value in chat box? Which is the most probable one based on the data we are having here? That will be your predicted output in a multi-class classification problem on logistic regression. Can I get some response? Which is going to be your output, which is O3, right? Because O3 is having 0.55, which is the most probable one among this. So that will be given as the output. If it's clear, we can start with the introduction about support vector machines. No, it's not 0.2, it's 0.55. Which is the maximum value here, it's 0.55, right? So if you sum up, it will add it to 1 or 100%. So this is 55%, this is 25%, this is 20%. Based on it, who is the most probable one, you can count like that. That is how a multi-class classification is done. Next, talking about support vector machines, you would have used support vector machine. S correct 0.55, which is an algorithm which has both support vector classifier and regressor. Okay, have you seen it? The data once again. So support vector machine are popular and powerful supervised learning algorithm which can be used for both classification and regression. And here what we are going to do is we will be using a hyperplane, okay, and support vectors. I'll tell you what it is. So this is how a support vector machine will look like. Okay, so you are having a data point, and first let us consider the scenario of a support vector classifier algorithm or classification problem. Here I am having two classes. You can see I am having the blue color one and I am having the red color one, right? So we are having two classes. And both of them are separated with this particular line. The line in the center you are having is called as a hyperplane, and these two extra lines I am having, right, that is called a support vector. So let us understand about them. For example, this is my data. I am having two different classes. One is red color, another one is yellow color. So this is my data set. Two different classes are available. I am plotting it, and what I am doing is I am trying to fit a line inside of it. Okay. So that line, I'll tell you how to find the best fit line in support vector machine later on. See here, once I have that line, what I'll be doing is I'll be getting a support vectors. So what is this support vectors? See here, the idea behind this support vectors is there should be one line, okay, which should be passing to the nearest of this particular blue color. Okay, which is the closest point here. For example, you are having a point here, right? So a line passes through the closest point of blue. That is one support vector of this blue color. And for green color, we are having another support vector which is the closest point. Okay, that will also have another support vector, and in between equal distance you will be having a hyperplane. Okay, this center line is going to be a hyperplane, and based on the plane we are separating it. And if you have a new point, you can classify easily based on the position. You can have it either this side or this side based on the output will be given. And talking about how to find the best, you can see right here, I can have this, okay, that for yellow color we are having a support vector, for red color it can pass through one or multiple, but it should be the closest or the least one compared with this. So we are having another support vector here, but you can ask me, I can do something like this and I can do something like this. Both are correct. Am I correct? See here, you can draw like this, support vectors and hyperplane, and this is also possible. So how the best one is selected? So that is selected which fit has the maximum margin. So what is margin? Is the distance between them. This inter distance, right? This value is going to be the margin, and for which you are having the maximum margin, that will be selected as the output. So based on that, this is selected here. You can see with your naked eyes here, it is very narrow. This is your maximum margin width available here. Now if you ask me, if I am having a data like this, then it is easily, I can separate it. But what if my data is something like this? Can you separate with a straight line? Is it possible? Can you have a support vector and hyperplane here which is passing through the closest between these two, which is not possible? You can draw here or here, where you will draw. So for that, what this support vector machine algorithm does is, it is giving you a additional option, I'll tell you. So this is what called as linear versus non-linear problems. When you draw it with a straight line, you cannot fit it actually. In such cases, we will be using something known as a kernel option here in your algorithm, which tries to find a decision surface which can be in 3D or any dimension with any feature. See here, roughly you can tell this, but if you have something like this in 3D, you can see, right, if I am having another plane which separate these 2 points, I can do the same by plotting a hyperplane for both of these, the support vector for both of this and a hyperplane, right? So that's how using kernel it can handle the non-linear data like this. With any of the feature, it will try to find a plane which separates them. And how SVM works, it is drawing an optimal hyperplane and the support vectors which passes through the least point from both the sides. And talking about the math behind it, once again it is a straight line. So let us consider a straight line of y equal to mx plus c, the hyperplane. And I am having 2 points. One is red color, another one is green color, 2 classes, right? And this belongs to -3 in x-axis and 0 in y-axis. This is 3, 3 in x and y axis respectively. And the value of c is where it passes the y, which is going to be 0 here. Let us consider the value of m as -1. With that, now what you are going to do is, we are going to substitute it here. Okay, so the parameter of this line is going to be m comma c will be -1 0. With that, if I perform this value, this is going to be the calculation, which is transpose of this value w, matrix multiplication with x. We will be doing for both of these points, one for P1 which is red color, another one for green color class. And you can see when I convert this -1 0 in matrix format and taking transpose, what is transpose? You can see, right, -1 0 can be written as this when you go for transpose. Okay, interchanging the row column. And when I do matrix multiplication with this -3 0, -1 into -3 will be 3, 0 and 0 will be 0. So this is 3, which is a positive value for red color. When I do the same for this green color, that will be -1 0 and 3 3. When I take it, okay, when I perform matrix multiplication, it is -3 and then 0 and 3 will be 0. So the value is -3. So this is negative. So what the inference from here is, for all the points which lie on the left side on the hyperplane, this value W transpose of X will be positive. If you have some other points which belong to the red color class, it will be positive. And those who are on the right side will be having a negative value. So if you are having a new data, okay, what you can do is you can substitute with these, and if it has positive value, it will belong to the red color. It will give you a prediction as red. If it belongs to negative, if the output is negative, then it will give the prediction as green. And this is the margin calculation with these formula. If you calculate it, you will be getting the value which is 2 by magnitude of this W, which is, this is the formula. When you have those 2 points, you can calculate, this is the value, right? Wx2 plus b. From these we can calculate these formula, and when you try to evaluate it, you will be getting output is this, and the target is to maximize this margin, right? And once again, this is for binary, that's fine. What if you have multi-class classification? Once again, it is going to follow the one versus rest. And with that, like we saw in linear regression, based on the probability, the output will be predicted. And talking about support vector regression, when we talk about classification, the idea is to fit everything, okay, which has the maximum margin. When you go for support vector regressor, this between this hyperplane, okay, between these support vectors, it is called as epsilon tube. And what is the idea behind this? You want to fit maximum number of points inside this tube. If you fit it, that will be the best fit. And based on it, you have a straight line, right? Now you can perform your regression and give you the result. And this is the formula for it, which is 1 by 2. And the value here is to be minimize this value. So every point should be maximum point inside of this. And in the chat box, there is a LinkedIn community and a Facebook community link has been posted. So it's free. If you are interested, you can join it, where you will be really interested. You can see a lot of people will be doing projects based on AI, machine learning, and you can scroll through the output of their projects also and assignments. So if you are interested, please join that community. The link is given in chat box. And to get your support vector machine, you can import support vector classifier as well as regressor from your sklearn.svm. You can import svc, which is classifier, and svr, which is regressor. And the kernel is a hyperparameter which you can optimize for getting the additional plane for nonlinear data. Can we start with decision tree, next algorithm? Is it clear till now? We have covered linear regression, logistic regression, and support vector machine classifier and regressor. So talking about decision trees, decision tree is a supervised learning technique which can be used for both classification as well as regression, but it is mostly preferred for classification problem, but you can utilize it for both classification as well as regression. So decision tree usually mimic human thinking ability. So it is actually easy for you to understand. So the logic behind the decision tree is to easily understood, okay, because it shows a tree like structure. You would have learned about tree based algorithms like in DSA and all, you maybe utilized it. So it uses the same thing. It is nothing but a lot of conditional statements. I can tell you simply, it is just a lot of conditional statements. So we will be having a decision node. Okay, this is going to be the parent or the root node, which will be having subtrees, and once it is ended, you will be having a leaf, or once you achieve a leaf, you cannot have further more branching. Okay, so you have leaf node, decision node, and the parent node. I'll explain. This is one of the common example to explain decision trees. It's a data set. You can see we are having columns like weather, temperature, humidity, wind. And finally, the prediction here is to find the place yes or no, which is a classification problem. So you have weather, which is sunny, cold, rainy, etc. So the task is whether if these are the features, the play is no, and if these are the features, the play is yes. You are going to map it with decision tree. So how it will work? So first, I'll tell you, we'll just start with weather column. Okay. So I'm going to start with weather and use a conditional statement. Weather is sunny. Okay. And the play is no. Okay, fine. And I'm scrolling below. Okay, again weather is sunny, the play is yes. So actually it is branching. Okay, it is not ending with the leaf. So I'm going to consider the next statement, which can be humidity. Here, see here, if it's sunny, I'm going with humidity, and humidity is high when weather is sunny, the play is no. Okay, so like that I'll be branching. But if you see the cloudy, see here, when the weather is cloudy, play is yes. Weather is cloudy, play is yes. Weather is cloudy, play is yes. So we have achieved a leaf because there is no further branching here. So whenever the weather is cloudy, it is yes. So if you have branching, then you will go till it reaches a leaf. So you will be splitting it based on the features. So that's how a decision tree works. Okay, I'll tell you with another example. See here, and go with these questions. So it is actually a guess the animal from decision tree. Okay, it's a game. It's an English language game. You want to predict this animal, you are going to guess it, whether it is having more than 5 legs. If it is yes, then you want to answer this question, whether it's hiding under your bed. Okay, if it makes honey, then it can be honeybee, right? So if it is not making honey, then it can be mosquito. Okay, if it is spinning web, then it can be spider or it can be bedbug based on this. Okay, and if it, like, sorry about the animal, it can be also including insects. So if it is having more than 5 legs, no means, then it is delicious means whether it can be a eatable one or non-eatable one. With that you are splitting. So like that the decision tree goes with questions and answers. So based on the human readable format you can interpret this. So now if you ask me, I have started with weather and then branched, right? So if you ask me, can't I go with temperature and start it, or can't I go with humidity, or can't I go with wind? You can. But how this algorithm is finding the best one? So with each one you will be getting different endings, right? So how will you find the best one is, it is based on this value which is called as entropy calculation and information gain calculation. Don't worry about the max, I'll explain you simply. Talking about entropy, in order to build a decision tree, we will need to decide what questions to ask and in what order. That is the important one, right? So in what order you are going to ask the questions. So entropy is a concept used to measure the impurity or disorder of a set of data points. Usually this entropy you used to hear in chemistry, right? So what is entropy for definition? Anyone knows it? So it's the calculation of disorder or randomness in a data, right? So when you are building a decision tree, so your final task is to minimize the entropy value, minimize the disorder or randomness. So the idea is to find attribute values or features that when you use for splitting will give you low entropy finally. So the calculation of entropy is this one. Okay, P1 log to the base 2 of P1 minus, so we need to take for other features also. So for example, if I am starting with this play goal, see here how I am calculating entropy is, I am having no which is 5 times and yes which is 9 times, which is 5, 9. So I will be substituting this in the entropy formula. If you get the percentage of it, what is the percentage here? So take for total is 14. So 5 divided by 14 will be 0.36 and 9 divided by 14 will be 0.64. This is their percentage, right? If you substitute this in the formula, percentage 1 0.36 multiplied by log 2 of this 0.36 minus 0.64 log 2 of 0.64, if you calculate it, you will be getting an entropy value which is 0.94. By the end, you should be getting a formula or value which is very low. So in which split you are getting low value, that can be the best one. So algorithm also uses another one which is information gain, which uses entropy once again. So now you know how to calculate entropy. So this information gain is another important concept related to entropy in decision trees, and it quantifies the reduction in entropy achieved by a particular split. So the formula is information gain will be entropy of parent. So parent is the parent node, their entropy minus weighted average of entropy of their children. Okay, what is this weighted average? I'll tell you. So the finally what will happen is you will be getting a value for information gain, right? So which algorithm or which split or which order of question is having the highest value of information gain, that will be your best fit. Okay, that order of questions will be your best fit. Okay, so if you go with information gain, if the value is high, then their entropy value will be low. That is the idea behind it. So you are achieving both entropy as low as well as information gain as high. And this is how you will be calculating the weighted average. See here, for parent I am calculating with this entropy formula. I know it, right? So this is the taking percentage and then getting the value out of 30. So I am getting the parent entropy, fine. So this is the parent entropy I am substituting here, 0.996. Then what is the weighted average is how many children that branch is having. So their entropy 0.787 and 0.391. Okay, so their importance in the percentage 17 divided by 13, okay, into 0.787. Okay, so this 17 how am I achieved? From this 13 and 4. Okay, and this 30 is nothing but this 17 plus 13, their children total count. So like that here also 1 plus 12 is 13 divided by 30 with this 0.391. This is the weighted average of the entropy of children. So when you subtract this, you will be getting a split information gain. So like that, if you calculate for, if you start with outlook and these guys are children, what is the gain value? If you start with temperature and these guys are children, what is the gain value? Okay, information gain. If you start with humidity, if you start with wind, you will be getting all these values. And what I have told you, which is the best fit? The one which has the highest information gain, right? So here, what is the highest information gain? Can you guys tell me which one is highest, whether it's outlook or temperature or humidity or windy? I can tell outlook is highest because of this 0.247, remaining things are smaller than that, right? So this is the best fit. This is going to be the parent, this is going to be the children. Based on this split, your algorithm will be giving you the output. This will be selected. And this is how it will be going with our decision tree, finally giving you the output. Is it clear about decision tree classification, how it works on entropy and information gain? Yes, correct, Nagasai. It's outlook, very good. What about others? Yes. So when you talk about regression, once again, decision tree regression, how it will work is, here the idea is to minimize the mean squared error value. Talking about mean squared error, it is the difference, the error value, right? When you square it and take a mean value of it, of the error, when you have seen in linear regression, right? In regression problems, that will be mean squared error, and it will try to split it based on the lowest mean squared error. So the idea is to reduce the mean squared error that will be taken. And mostly this algorithm is preferred for classification. So if you are going for regressor, I'll suggest you to go with some other algorithms, but you can use it. Okay, you have both decision tree classifier as well as decision tree regressor. And it's particularly used mostly in classification problems. And quickly we'll see about ensemble algorithms. Okay, so we have bagging algorithm and boosting algorithm. Bagging algorithm we have random forest, and boosting algorithm we have XGBoost and AdaBoost, CADBoost, some more like gradient boosting algorithms also, right? So first we'll understand what is bagging, what is boosting. So all these comes under ensemble algorithms. Talking about ensemble algorithms are machine learning techniques that combine the predictions of multiple individual models, are called as base model or weak learners. So here you are not having one iteration, you will be having iteration of your algorithm. Imagine if you are having a decision tree, if you run it 100 times and based on the 100 output, you are giving one result, that will be really good, right? So that is what happening in ensemble algorithms. So ensemble method not only uses one time, it uses multiple individual models. Okay, so ensemble method are powerful because they can reduce overfitting, improve model generalization for your new data, and enhance predictive performance compared to a single model. So what is bagging is, it involves creating multiple bags of your data. Imagine you are having a data, okay, you are having 1000 rows. So what it will do is it will split them into parts, 200 rows, 200 rows, 200 rows, 200 rows, like that, and give to 5 different algorithms. So they will be giving result, right? So it will interchange and get the result. So one such bagging algorithm is random forest. And random forest, the name is achieved because it uses multiple decision trees. If you have a lot of trees, it is a forest, right? So it is a random forest algorithm. So this is how you are having multiple decision tree, your data, okay, the data set is bagged into different parts and given to different algorithms. Okay, so every data will once again pass through this. So this guy is giving a result, this one is giving a result, and this is giving another result. So what will be your final output is voting or average. What that is, if it's a classification problem, then random forest classifier, what it will do is, if this guy gives us yes, this is given as no, the third one is also given as no, then your final output will be based on voting. So no is the majority, so no will be your final result. So if it's a regression problem, if this guy given the output as 3, he given as 4, and he given as 5, it will try to take average of these 3 value. How many algorithm? That many output average will be taken. So 3 plus 4 plus 5 divided by 3, that will be your final result. That's what voting or averaging is. And you can utilize from sklearn.ensemble. You can import random forest classifier and random forest regressor. And talking about boosting algorithm, so this is like boosting. Okay, so nitro boost or something like that, which focuses on improving the performance of weak models or for weak data. So we have algorithms like ADA boost, gradient boost, which is XG boost, light GBM, cat boost, and adaptive boosting also. Talking about adaptive boosting or ADA boost. So here it is a boosting algorithm. Okay, so first time it is not going to run parallel algorithms. First time it will start with one algorithm. So this is the first model. Original data set will be given. So it will be giving some predictions, right? So it will have the testing data also. It will correct and give you what are all the wrong answers or wrong output that will be assigned to more weight. For example, in an exam, if you know that you are weak in a subject, what you will do, you will give more time and learn more about it, right? So that is what happening here in your ADA boost. So for the next model to run, it will assign more weight, so that more importance for the wrong predicted one, and that will be given to model 3 and so on. So that's how ADA boost works, and you can utilize classifier and regressor from sklearn.ensemble. And talking about XG boost or extreme gradient boost, so here what it will do is, it is also going to give the next algorithm based on the failure outputs. So what it will do is, here you will be getting one output, right? So who are all is the wrong output, what is the error value, that will be passed to the next one. So every time it runs, it will try to minimize the error. So that's what the XG boost is. And another important feature is, the XG boost has the ability to handle missing data. Okay, so XG boost can automatically learn how to handle missing data. So if you are having a data set which is having lot of missing values which you can't handle, you can't manipulate, I'll suggest you to go with extreme gradient boost algorithm. So this you want to install, you won't be having it from your sklearn. You can install XG boost and then import the classifier as well as regressor. Okay, so next we will see a glimpse about K nearest neighbor algorithm. So as the name itself suggesting, so the KNN algorithm is a type of algorithm which can be used for both classification and regression. So it is based on the similarity. So the K value you will be passing. So if I am passing 5, so 5 nearest neighbor value from your data will be taken, and based on their average or majority, the output will be given. For example, like this. I am having a new data, means look at that data. You are having 3 classes. One is something like a light green, a dark green, and orange color. So you need to calculate. Okay, if I am giving the K value as 4, see here, the nearest 4 points, this guy, this guy, this guy, and this guy, their values will be taken. What is their distance will be plotted here based on the K value which I have given. So based on that, you can find the majority here is this light green. So your new class will be that green. So if you go with K value as 10, then you want to consider the distance and who is the majority. And when you go for regression, average will be taken. So if I go with 4 values, what is the output of this guy? What is the output of this guy? Like that. If it's 4, their average will be taken. So imagine this situation. This is 2 classes available. So I'm having a new one which I need to predict who is, it belongs to red or blue. So based on the nearest K value which I am giving, for example, if I given as 2, then if you go with the 2 nearest value or 3 nearest value, you can find red is the majority. This is the closest to this guy. So output will be given as red color. So it's an example. So if you assume the K value as 5, so if your data is this, you can calculate what the new class, if its brightness and saturation is this. So you can use this formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. Once you apply it, you can find their distance for each point, and you need to arrange it in increasing order, and then you can get the 5 closest point. Based on that, you can see we are having red, red, blue, blue, and red. Red is the majority, so the output for that new point is going to be red. So you can select the K value and calculate the Euclidean distance with that formula, and take as per that. You can, if it's a classification, majority vote, and if it's a regression, the average value. And you can also utilize a for loop. Okay, using a for loop, change the neighbor value and plot the result of the error. If you plot it, if you get something like this, you can find at which point your error value is less. minimum error, that you can utilize. Here this guy got it around 37 minimum error, so the nearest k value he can use is 37, which gives him the best result. So you want to utilize something like this, your Python skills also, to achieve some output like this. And you can utilize both KNN classifier and regressor, and you can achieve this result. Fine. And finally, we'll see only one clustering algorithm. With that, we can wind up our session. This is an unsupervised machine learning algorithm, which is k-means clustering. So idea behind unsupervised learning is you won't be having any label or target. You cannot map. And if your task is to use clustering to find groups similar together here. So this algorithms will cluster them like that. You can see right here, I can see that this belongs to one group, this is another group, this is another group. So like that, this k-means clustering, you need to give the k value. If I give the k value as 2, then it will try to split them into two groups. If I give us 3, then like this 3 will be splitted. If I give us 10, then 10 should be splitted. Okay, so based on the centroid it will work. And to find it, you can use this WCSS value, which is nothing but within cluster sum of squares, which is nothing but, if I am having a centroid, what is a centroid? Is a center point for all these clusters. If there are 3 clusters, then there will be 3 centroids, and the value of WCSS will be the distance between the point and their centroid. Okay, so initially if I am having one centroid here, center I am having only one centroid, only one cluster, then the distance will be very large. Okay, so if I am having 2 clusters, then their distance will be somewhat reduced. So if I am having further more clusters, the value will be keep on reducing, right? So what we can do is, you can use a for loop and utilize this k-means algorithm from sklearn. Okay, and then you can calculate this WCSS from, actually there is an option called inertia in that algorithm, which will give you the WCSS value automatically. So once you have it from 1 to 10 and plot it, you will be getting a curve like this, because when the value of W or value of cluster is less or 1, the WCSS will be high. I told you why. When you keep on increasing it, the value will keep on decreasing. And how to find the best point here is, you need to find this elbow point. Okay, which is this like elbow. You need to find a point which is having the elbow. So that here it is 3. That is actually the good k value for your algorithm. So you can go with that one. Okay, you can use a for loop and fit every time and then achieve this. So that's all about our k-means clustering. Talking about the last point, which is model evaluation. Once again, if you know about all these algorithms, for your particular data, you can use hyperparameters to optimize it. And also you can, every time you can use model evaluation to evaluate it. Like model evaluation is the process of using different evaluation metrics to understand a model's performance and its strength and weakness, right? So for classification problem, you can use accuracy score, precision, confusion matrix, etc. and classification report from your ROC curve, etc. can be utilized from sklearn.metrics. For regression kind of problems, you can use error calculation, R2 score error, mean absolute error, mean squared error. Once again, the error is calculated in different formulas. Okay, so that's it about our 1 hour on machine learning algorithms. I have tried to give you an overview and math behind a lot of algorithms. We have started with linear regression, logistic regression, then support vector machines, classifier and regressor, decision tree classifier and regressor, ensemble algorithms, bagging, XGBoost, and boosting. Okay, bagging we have random forest classifier and regressor. In boosting we had seen about AdaBoost and XGBoost, then k nearest neighbor algorithm. Then in clustering we have seen about k-means clustering and model evaluation tools also. So you can utilize these tools from sklearn.metrics. So that's it. Thank you. So you can post your reviews in the review link which is given. I hope this session was nice from my side. You can post your reviews in the link which is given in the chat box. Thank you. And actually we are having an internship which is running right now. The link is given in the chat box previously. If you want, you can join in a machine learning internship, which covers the basics of Python, then a lot of machine learning concepts also, and then algorithms, math behind it elaborately, hyperparameters tuning, and now we are in projects. So if you enroll as an internship user, you can watch those sessions also, and you can also watch the further sessions. We are also having Zoom class where you can interact with me directly to clarify your doubts, and also we are having sessions where we'll be discussing about Kaggle competition, etc. So you can utilize that link. It is available at a fee of $799. If you want, you can join, enroll as an internship user and get certified in machine learning. Thank you.